We're going to look at this last section on applications of trig functions. So solving right triangles and some word problems. So first thing you've got to note is basically how do you build it. This should have been covered in geometry, but you know, hey, if you didn't see it, let's get it now. It's typically done when you solve a right triangle. They normally use A, B, and C. The capital letters are always your angles. The lowercase letters are always your sides. And they are opposite each other. So, like, I guess you can see how this is going. Angle A is opposite of little side A, and so forth and so on. Angle C is always and forevermore the right angle. And the reason that is because you remember good old Pythagorean theorem. You know, that was always C squared. C is always the hypotenuse. Well, if angle C is the right angle, well then, yeah, look, little c is the hypotenuse. So it works out well. It really doesn't matter whenever you're constructing your little triangle, if they didn't draw it for you, if they just kind of told you some measurements and you're drawing it your own, it doesn't really matter which place you put A and B, as long as you put little a opposite big A. If you keep that in mind, if you draw yours, it's fine. Now for Algebra 3, we're going to take off these minutes because y'all didn't use those. We'll just use it with 34 degrees. So it says solve the right triangle. And you know that A is 34 and little c is 12.7. Now I'm just going to do one of these solving the triangles. It can have a different flavor to it if I just give you two sides. But to keep it simple, you're going to be able to use Pythagorean theorem. You're going to be able to use the idea of complementary angles. And you're only really going to have to use trig once. I would keep in mind to use what is given in the problem. Go back to it as much as possible. That way, if you do make an error, you don't compound your error again and again. So, what it means to solve a right triangle, you've got to find all of your angles and all of your sides. So to keep my head straight, I like to list. I'm a list maker. Okay, they told me A was 34. Now, what do we know about angle C? Well, he's always 90. Yay. And then little side C is 12.7. All right, you can make your triangle however you choose. He just needs to be a right triangle. I have the habit of putting A up top and B down the bottom. That's just me. I know that doesn't look like a 34-degree angle, but that's okay. A and B have to be complementary because 90 degrees has already been eaten up by C. So 90 minus 34. 90 minus 34 is 56. So 56 goes right here. You've got one thing off the to-do list. Now, this is going to be little a, this is going to be little b, and c is 12.7. Now, you have a choice to make, and you have to make the choice to make any progress. You have to pick. Do you want to do little a or do you want to do little b? I might as well go in ABC order. So I'm shooting at little a. I'm going to use big A. I don't know, but you have to pick. Well, of course I'm using big A because that's my angle. I didn't have a choice there. My bad. So I have this angle. I have this side given. I have to use those. But I'm looking for this guy. From this angle, this side is opposite. This side never changes. He's hypotenuse. But which trig function is opposite of hypotenuse? That would be sine. So sine of 34 degrees is little a over 12.7. So I need to solve that. I'm going to make a proportion. So I'm going to put that over 1. A times 1 is A. And 12.7 times sine 34 is what that's equal to. Now I purposely take my number and I put it before the trig value because I don't want my number running into my angle. It causes problems when you put it in your calculator if you don't close parentheses. So it's just so much nicer to just type him in first, 12.7, then hit sine 34, and you don't even have to worry about closing the parentheses. So 7.1 works out well. Okay. Once you get that, you have the freedom now to go Pythagorean theorem. Now, if you would like to use trig for the other part, that would be wonderful, but you do not have to. 7.1 squared plus b squared equals, where's my equals? Equals 12.7 squared. So in your calculator, it's 12.7 squared, and then you subtract 7.1 squared. Now, you don't necessarily have to write this. Do your square root of your answer, which is your second negative button, and I get 10.5. Once you get all of your little spaces filled, you are done. You have solved the triangle. There you go. It just takes practice. These aren't hard. They're just long and annoying. So we're going to skip this one just because they're long and they're time consuming. Let's look at some word problems. One of the things that you're going to run into is angle of elevation and angle of depression. They happen quite a bit. Most kids tend to be okay with angle of elevation. They don't seem to have too much trouble with that. Here's elevation. Because they know that's going up. That makes sense. Where they get confused is with depression. Too many of them put it with the vertical. It's never with the vertical. It's always with this line of sight. From your line of sight, how much did you look down? So this right here is the angle of depression. Now if you think about it, your line of sight should be parallel to the ground. If that's true, and this right here is your transversal, then your angle of depression here corresponds perfectly with your angle of elevation. You can actually, those are equivalent every time. So anytime it says angle of depression, you can always take this value and put him down here where angle of elevation would be noted and just roll with it. You do not have to subtract and figure out what's up here. That's not necessary. You can just use alternate interior angles being equivalent. So let's just look. And again, let's just take off the minutes because you guys didn't do that in Algebra 3. Okay. It says that she knows that where she stands is 123 feet from the base of a flagpole. Now, for those of you that don't know me, my art is lacking. I'm artistically challenged. Doesn't take long to figure that out. Okay, so she is 123 feet from the base of the flagpole. That's great. Angle of elevation to the top of the flagpole is 26 degrees. Okay, now this is from where she's looking as well. So, to the top. Angle of elevation, 26 degrees. If we're assuming she's standing up straight, right? If her eyes are 5.3 feet above the ground, find the height of the flagpole. Well, you're wanting this, right? Well, to start with, you've got to get this part. So you need to be noticing this triangle right here, okay? It's all based on this angle. This angle, that means this side is opposite, this side is adjacent. Which trig function is that? Tangent 26 equals x over 123. Put that over 1, cross multiply. X equals 123, tangent 26. Okay, let's run that through our calculator. We got 123, tangent 26. I have, oh, it's really super close to 60, so let's just round up to 60. So this is going to be 60 feet. This part, 60 feet. Well, you know her eyes are 5.3. I don't think my point showed up very well. 5.3 feet. So the total height is going to be 65.3. So total height of the flagpole is, what did we say, 65.3 feet. There we go. But you just had to add that back in there. Okay? So be prepared to deal with angle of elevation. Let's look at this one because it's angle of depression. I think this will be all that we have time for. It says from the top of a cliff that's 210 feet, so we know this much. It says David observes a lighthouse that is 430 feet offshore. Now, that doesn't make a whole lot of sense to me why the lighthouse is offshore. Maybe it's on an island somewhere. Okay, so find the angle of depression from the top of the cliff to the base of the lighthouse. So we got a little lighthouse off here, and maybe he's on an island. I don't know. Okay, and we got some water. Okay, yeah. I told you my art was pretty bad. Okay. It said it is 430 feet offshore. That's how far. It did say find the angle of depression. Now keep in mind what we talked about earlier. Here's the dude. Angle of depression is how far you look down. But that corresponds perfectly to angle of elevation. So once again, we've got opposite and we've got adjacent. So tangent of this unknown angle is 210 over 430. So this is what we're looking for angle. You need inverse tangent. So grab your calculator. You're going to hit your blue button, your second button, tangent, and then type your fraction, 210 divided by 430. And I get my angle to be 26 and change. So we're going to round it to 26 degrees. There you go. Y'all just practice some. Let me know if you need a little extra help.